Welcome back to the Deep Dive. Today, we are really cracking open a concept that basically defines how useful AI is right now, retrieval augmented generation. You'll hear it called RAG.
Right. And for you listening, RAG is really the secret sauce. It's what lets a large language model, an LLM, look outside its training data.
So it can ground its answers in, specific, up-to-date, factual
Concrete
documents.
documents.
Exactly. And that ability is critical. But what we're seeing now is a huge shift. The goal is still the same. We want the best possible answer from your sources, but the method is changing dramatically.
Yeah, we're moving from a simple sort of static process to something way more dynamic, more intelligent, frankly.
It really is. And that's our whole mission for this deep dive.
That's right. We're going to break down the fundamental difference between what we'll call traditional RAG and this new evolution, agentic RAG.
And it's not just a small update. This is a totally different way of thinking about the problem. It swaps a fixed pipeline for actual dynamic decision making. And if you want to understand why some AI tools feel rigid and others feel like these incredibly adaptive assistants, this is the key. So let's start with the baseline, the traditional approach.
Right. Traditional RJ. It's the workhorse of enterprise AI at the moment, and it's popular because it's beautifully efficient. It's a linear process.
All about execution and speed. A pipeline.
A pipeline. That's the perfect word. It's all about retrieval-based generation.
Okay, so let's walk through that linear process. We've got our knowledge base, maybe thousands of documents, company data, and the model needs to reference it. When I, as a user, type in a question, what happens? What are the steps?
Okay, so there are 4 very clear stages, and they happen in sequence, one after the other, no turning back. First, your documents are prepared, turned into these numerical representations called vectors.
Right, and when I ask my question, my query gets encoded into a vector too.
Exactly. So we've translated the meaning of your question into a kind of mathematical coordinate.
It's semantic location, basically.
You got it. So step 3 is the search. The system takes your query vector and searches a vector database to find the document chunks that are mathematically closest.
It's just a similarity match. It finds the nearest neighbors in the data and just pulls them out.
Precisely. And in the final step, the LLM gets the original user query and that set of documents it just retrieved. It puts them together and generates the final response.
It's clean, it's fast.
Yeah.
But you mentioned a limitation.
Here's the critical piece. The initial query you put in is static through that whole process. It's an instruction that just gets executed. There's no room for it to, refine the query or double check what you really meant.
That fixed nature. That's the ceiling it hits, isn't it? If my query is a little ambiguous, like, what's the latest policy on mergers?
Right.
The system might not realize I need the actual policy documents and the most recent press releases about it.
Yeah.
It just retrieves based on keyword similarity.
Even if those documents don't actually answer your real intent. So you get the situation, garbage in, fast execution, but maybe, suboptimal context out.
And that's where the whole landscape just fundamentally changes.
This is where it gets really interesting.
Okay, so for you, the learner, this is the solution to that rigidity. Agentic RAG. The process starts the same way. You type in your query.
But immediately, we add one single crucial element, the LLM agent.
And this is the turning point. We're going from that fixed pipeline
to dynamic orchestration. The agent's main job isn't retrieving documents or even writing the final answer. Its core function is to think and to decide on the best workflow.
So it's not the librarian fetching the book. It's the research assistant planning the whole investigation. How does it know what to do, though? What makes it smart?
It's an LLM that's driven by a really powerful meta prompt. Basically, a set of instructions that tells it to be an orchestrator. So when it gets your query, it immediately evaluates it. It asks itself questions.
Like what?
Like, is this query complex? Do I need to use an external tool for this? Is it ambiguous?
An external tool. Give me an example. What would it call for besides the vector database?
Oh, it could be anything. It might call a specialized API to get real-time stock prices. It could call a code interpreter to run a calculation. Or, this is a big one, it might decide to use the LLM to rewrite your original question into 3 much more specific subqueries before it even starts searching.
Whoa.
It has the agency to call for additional actions.
So instead of a passive system that just runs one search and hopes for the best, we have this active decision-making layer that says, hang on, that's a vague question.
Hmm.
I need to break it down. I need to refine it. Maybe I need a tool, and then I'll start searching.
Exactly. We have injected a layer of dynamic decision-making and context awareness that traditional RAG just completely lacks. The agent figures out the workflow and, critically, decides if more refinement is needed before you even get to the final answer.
Okay, let's drill down into the mechanics here,
Mm.
because this is where the speed of traditional RAG starts to look like you're sacrificing quality. We need to focus on the two main areas where this agent changes everything: handling the query and then generating the final response.
Right, and when we look at query handling, the difference is it's stark. This is where the agent really earns its keep.
Okay, so in traditional RAG, we said the query is static, one and done. What happens when that one shot doesn't quite capture what I really meant?
Well, if the query is a little bit off, the vector search retrieves chunks that are similar in topic but maybe irrelevant. We call it semantic drift.
Ah,
So the LLM gets the suboptimal context and has to try and build a good answer from it, which can lead to vague results or even hallucinations just because the source material was weak.
and Agentic RAG is designed to stop that from happening proactively.
Yes. The LLM agent actively evaluates and updates the query. It might see a query like, what were the sales figures for Q3 and the major management changes from the press release, and break it into two separate optimized searches.
So search 1 would be Q3 sales figures financial document.
And search 2 would be management changes press release announcement. It's performing effectively recursive querying. It can search, look at the results, realize they aren't good enough, and then modify the query and search again.
That's a key feature.
And it can go even further. The agent can introduce confidence scoring and might retrieve some documents, check the similarity score, and decide, this confidence is too low.
And instead of just passing those mediocre documents along,
It triggers a second modified search. It's optimizing the input to guarantee a much higher quality output.
that focus on quality control is a massive shift. But, okay, let's address the elephant in the room. If the agent is running an LLM call to refine the query, then searching, they may be running another LLM call. Doesn't that make everything way slower
Mhm.
and more expensive?
That's a crucial trade-off. You've hit on the biggest point of divergence right there.
I thought so.
Yes, agentic RAG adds complexity, and that means higher computational cost and definitely higher latency than the simple single-pass approach. Traditional RAG is still going to be better for simple, high-speed fact-checking where you need an answer in milliseconds.
So traditional RAG for speed-critical, simple lookups. Agentic RAG for complexity and accuracy, where speed isn't the #1 priority.
Precisely. You're trading a bit of a delay and cost for huge gains in accuracy and robustness, especially with complex data.
All right, let's move to that second big difference: final response generation. In the old way, once the documents are found, it's hands-off. The LLM gets the context, synthesizes an answer, and that's the end of the story.
But in agentic RAG, the agent stays in the loop. It remains pivotal through the whole generation process. It's acting as a final quality check.
How does that actually work? What decisions is the agent making after the documents have been pulled?
Well, it might see that the retrieved documents contradict each other. Say there are two different versions of a policy in the database.
Oh, that happens all the time.
Right. A traditional system might just pass that contradiction along. The agent, however, can be programmed to spot that. It could then trigger a secondary search just to find the effective date or the superseding document. It imposes these structured quality checks.
It's fascinating. It's not just summarizing information. It's actually resolving conflicts in the source material before it even shows you an answer. It's performing validation.
Absolutely. The agent is responsible for ensuring the coherence and the trustworthiness of the final response. You can even tell it to follow a specific output structure, like the answer must include a citation for every claim, and if a claim can't be cited, you have to flag it.
And that agency is what leads to those much more accurate, more context-aware outputs.
That's the whole game.
So what does this all mean for you, the person actually using these tools? Why go through all this trouble? Let's connect the tech back to the real world for us.
The so what is all about adaptability and resilience. Traditional RAG is great for the straight, narrow path. Agentic RAG is for when the query, leaves the paved road. The benefits are clear. More flexibility, dynamic evaluation, real-time adjustments.
I can see how that would be critical in fields like, I don't know, legal or financial services, where data sources are constantly changing or have all these complex, interconnected policies.
It just makes the system so much more adaptive for those really ambiguous queries. Let's talk about some specific applications.
Okay.
First, think about compliance checks. Imagine you ask a system, does our new vendor contract comply with the privacy standards in our 2023 internal policy?
Okay.
Traditional RAG would probably pull the whole contract and the entire policy document, hundreds of pages, and just tell the LLM to figure it out.
Which is a huge task.
A huge and unreliable task. The agentic system is much smarter. The agent first identifies the specific clauses in the policy, data residency, data destruction, whatever, and then uses those clauses as targeted subqueries to check the contract line by line.
So it's using the policy as a rubric, not just as raw context.
Precisely. It delivers a structured report, not a summarized guess. Or think about another one, synthesizing contradictory data.
Right. Data from different silos. A spreadsheet says one thing, a report says another.
A traditional system often just averages them out, which is so dangerous. The agent's ability to self-reflect and check confidence scores lets it spot the contradiction. It can actually articulate the conflict back to you or ask for clarification instead of giving you a blended, totally unreliable answer.
It's resilient against messy data.
Exactly. And let's go back to that multi-step query because that's where traditional systems almost always fall down.
Yeah, that's the most common failure point I see.
Absolutely. So if you ask, summarize the earnings call, then calculate the year-over-year revenue growth from this spreadsheet, and then draft an internal summary. That's 3 distinct tasks.
Retrieval, tool used for the calculation, and then synthesis.
And Agentic RAG handles that workflow sequentially. It does the retrieval, it passes the spreadsheet to its calculation tool, it gets a definitive number back, and then it synthesizes the full report. It ensures the answer is grounded in both the text and that hard number.
That's really the difference between asking a simple question and asking for a completed research project.
It is. The agent is the research assistant. It makes sure all the steps are taken in the right order and that the quality is high at every single stage.
It's all about building trust in the final output.
That's the goal.
Fantastic. Okay, let's bring this all home. If you take one thing away from this deep dive, it should be this core distinction. Traditional RAG is a static, linear pipeline. It's fast, it's efficient for simple things, but it's rigid.
Right. And Agentic RAG is a dynamic, orchestrated process. It's driven by continuous decision-making and self-correction by an LLM agent. And while, yes, it has more latency and cost, it delivers massively better accuracy, resilience, and the power to handle truly complex analysis.
That ability to pause, decide, and self-refine really feels like the future of intelligent information retrieval. And, since the agentic method provides these real-time adjustments, it's moving beyond a fixed pipeline toward autonomous planning. That raises a really important question for you, the listener, to think about.
It does. If the agent can not only refine the question, but also decide which tools to use, what external systems to consult, and even create a new plan when the first one fails, what does that mean for the very definition of information discovery? We are moving so quickly toward AI systems that don't just answer our questions, but actively design the research plan needed to find an answer, sometimes without any human intervention at all. So how far will this ability to self-refine go? Especially in these complex, constantly changing data environments, that's the powerful thought to really mull over.
That is a great place to leave it. We hope this comparison helped you really understand the key differences and the powerful advantages of these agent-driven models. Until next time, keep digging deeper.